Hi guys, welcome to my channel, and today let's learn BGP. So here we are going to configure OSPF BGP synchronization. So first of all, it's important to understand what BGP is. So BGP is a short term for the Border Gateway Route Protocol, which is an advancement of the Exterior Gateway Protocol, which was used before. So Border Gateway Protocol is a distant vector protocol that allows devices between autonomous systems to communicate and also exchange the optimal routes. So Border Gateway Protocol is divided into, when I say autonomous system here, what I'm referring, autonomous system is a group of IP networks that is controlled by one entity, and the entity I'm referring to here is the, let's say, the internet service provider, and are controlled by one routing policy. BGP is divided into two, so that is the IBGP and the EBGP. So that is Interior Gateway Protocol and the Exterior Gateway Protocol. Interior Gateway Protocol runs within an autonomous system, while the Exterior Gateway Protocol runs between autonomous systems. Like for instance here, autonomous system 10, this switch 1, switch A, switch C, switch B, and switch D here. These are IBGP. They are going to create the IBGP peers because they are within the same autonomous system, that is AS10, while switch E here is on a different autonomous system, that is autonomous system 20, and it's going to establish EBGP peer with switch D here. So that is what we are going to ensure, that we are going to ensure that routes from switch D here are reachable on switch E. Let's see the requirement for our configuration. So this is, the requirement here is on the network shown. An EBGP connection is established between switch D and switch E. IBGP connections are established between switches in autonomous system 10, and OSPF is used as an IGP protocol. OSPF BGP synchronization needs to be enabled on switch B so that the traffic from switch A to autonomous system 20 will not be interrupted after switch B restarts. And take a note here. In this scenario, ensure that all connected interfaces have STP disabled. If STP is enabled, and VLAN-if interfaces of switches are used to construct a layer 3 ring network, an interface on the network will be blocked. So as a result, layer 3 services on the network cannot run normally. This is the topology. We are going to configure. Then the roadmap: configure IP addresses and VLANs for the VLAN-if interfaces on switches to implement communication within network segments. Configure basic OSPF functions and IBGP connections on switch A, switch B, switch C, switch D, excluding 10.2.1.1/30 to implement a device connection within autonomous 10. Configure exterior border gateway protocol connection between switch D and switch E, and import direct routes and OSPF routes to implement communication between autonomous 10 and autonomous 20. Set the OSPF protocol cost to on switch C so that switch A selects only switch B as the intermediate router to the network segment 10.2.1.0, and switch C becomes the backup of switch B. Enable OSPF BGP synchronization on switch B so that the traffic from switch A to autonomous 20 will not be interrupted after switch B restarts. So that's the requirement, and that's what we are going to configure. In this practical, the prerequisite here is that you know how to configure the interfaces, like configuring layer 2 and also giving the VLAN-if interfaces address. So you are required that you can create on yourself, you can configure an interface and give it a a link type, and also configure IP addresses. So like for instance, gig 1 here, this one is going to allow VLAN 20 to pass, and this gig 1 on this other side is going to allow VLAN 30 to pass, and you should be able to configure that, because initially I had said that. So here what we are going to implement is actually just how can you configure BGP, IBGP and EBGP. So the importance for BGP is that it selects optimal routes. Also, it caps loops in our network, and also maintains multiple routes. So let's see on these our devices, and these are devices we have configured this CU, and see what have been configured. So we've configured IP addresses on the interfaces. We've created VLAN 2030. And this CU VLAN 2030, and have been given IP addresses, and the interface have been allowed to allow the respective VLANs to pass. Also, when you come to switch B here, display CU, we configured VLAN 10 and 40, and we've given them IP addresses. And let's see if the respective interfaces have been allowed to allow the VLANs to pass. So we've allowed VLAN 10 and 20 to pass. So those are the things I told you should be able to configure. And on this switch here, this CU, and the same also have been given IP addresses, and the respective VLAN have been allowed to pass. This CU again, VLAN batch 2030 interface, VLAN if 10 have been given IP address, and the respective VLANs have been allowed to pass. So after you've confirmed that the interfaces are up, and also the VLAN if interface have been configured for the layer 3, the next thing we are going to do is now to enable communication within our autonomous system network by configuring the OSPF. So we are going to configure OSPF here. The area we are going to set to 0 at the backbone. So, and route ID, we are going to use the loopback interfaces. So OSPF, OSPF process ID, let's use 10. Then route ID here will be 10.10.10.1. Area here is area 0. Then we have advertised the network that connect to that switch. So the network that connect to that switch will be, start with the loopback network. So network of 10.10.10.1, wildcard mask of 0.0.0.0, because we are configuring on 32 best. So we'll use that wildcard mask. Then we advertise the network of 10.1.1.1, wildcard mask of 0.0.0.0 to ensure it's a 32 best. The next network we are going to advertise is a network of 10.1.2.1, wildcard mask of 0.0.0.0. Then you quit. And you also come to this switch here, and configure OSPF process ID of 10. Route ID here will be 10.10.10.2. Area here is area 0. Area 0, we advertise the network of 10.10.10.2, that is the loopback, a wildcard mask of 0.0.0.0. The next network we advertise will be the network of 10.1.1.2, wildcard mask of 0.0.0.0. Then we advertise the network of .3, 10.1.3.1, wildcard mask of 0.0.0.0. As you can see, let's display OSPF. Display OSPF peer brief. When we display the OSPF peer brief, there is no we don't have any entry, meaning that the neighbor relationship has not been established, and also the routers have not been able to exchange LSS. Why is it so? Because when you look at this our network, there are loops in our network. So the thing we are going to do, we are going to disable STP on the interfaces that are connected to those switches. So you get enter interface gig 0/0/1. Then you disable STP. So STP disable on those interfaces, and you should see it exchanging LSS. As you can see, it's now exchanging LSS, and the neighbor state is now full. It has the neighbor state is full. The neighbor state was established, and now the state is full. Also enter gig 2 and you disable gig 2. Also you disable STP. You come to this, the same you do to this guy. Also you quit and enter interface gig 0/0/1 and STP. You disable STP, and gig 2 also you disable STP. You disable STP, then you quit and you save those configuration. Save. Also you come to switch C here and you advertise the routes, you advertise the networks so that they be able to exchange the LSS in the IBGP net in the interior gateway, that is autonomous system 10. So OSPF process ID of 10, router ID here will be for the loopback will be 10.10.10.3. area here is area 0, and our network here, the network here will be 10.10.10.3. that is for the loopback wildcard mask of 0.0.0.32 based, and we advertise the network of 10.1.2.2 wildcard mask of 0.0.0.0. Advertise the network again of .4. It's exchanging LSS now successfully. So network of network of 10.1.4.1 wildcard mask of 0.0.0.0. You quit and enter the interface that connect to those devices. So interface gig 0/0/1. You disable STP disable. You disable STP. Also enter gig 2 and you disable STP. So the neighbors that has been established will be 10.10 and 10.1.2.1. display OSPF peer brief. So when you display OSPF peer brief, you see the neighbor here and the state is full. Now you come to this switch that connect to our switch D here that connects to the EBGP. Now OSPF, the process ID of 10, router ID here will be 10.10.10.4. area is area 0. In area 0, we are attached the network of 10.10.10.4. wildcard mask of 0.0.0.0. Another network we are going to advertise will be 10.1.4.2. wildcard mask of 0.0.0.0. Then it's now able to exchange the LSS. And the next network we advertise here will be, the next network we advertise here is network of 10.1.3.2 wildcard mask of 0.0.0.0. Then the last network will be the network that connect to the EBGP, will be a network of 10.2.1.1 wildcard mask of 0.0.0.0. So then display OSPF peer brief, and display the OSPF. You see they have established a neighbor with VLAN if 30 and VLAN if 40, and the router IDs are given there. After configuring our autonomous system 10, that is configuring IBGP to make routes reachable, the next thing we are now going to configure is to configure the IBGP itself. Now I'm going to create the peers because this one is autonomous system 10. So you enter, so BGP here, we are going to use 10. On BGP 10, we are going to create peer. The peer we are going to create for loopbacks or loopback 10.10. We are going to create the BGP based on the loopback interfaces .2. Then autonomous system number here will be 20. Autonomous system 10, not 20. That is IBGP. Then after creating that, because this one is a loopback interface, it's a logical interface. After that, you tell it to connect to that logical interface. So if it was a physical interface, we didn't have to configure this. So because it's a logical, you have to configure. So say peer 10.10.10.2 connect to the loopback interface of 0. Then the next thing will be peer 10.10.10 for switch C, that is .3. AS number here will be 10. Tell it to enable IBGP peer with switch C. Then you tell it to connect to that loopback interface 10.10.10.3. Connect to loopback interface loopback 0. Loopback 0. Then you create IBGP peer with switch D here. So you say peer 10.10.10.4. The S number here will be 10, and tell it to connect to the loopback interface. So peer 10.10.10.4 connect to loopback interface 0. After that, we are done. So let's display that. Display this. And display, you can see the peers have been enabled. You come and do the same to this other. On this other switch here, we are going to connect to the loopback of switch A, switch C, and switch D. So you come on that loop, that. So BGP here is 10, BGP 10, and peer, we are going to sell it peer. The network of 10.10. The loopback for switch 1, 10.10.1, AS number here will be, AS number here is 10. And that, after that, we tell it to connect to that loopback because it's a logical interface. So 10.10.10.1 connect to loopback interface 0. Then you create a peer with switch C. So peer 10.10.10.3, IS number here will be 10. Then you tell it peer to establish a connection with the loopback interface, that is 10.10.10.1 connect to loopback interface. Connect to loopback interface 0. Then you are sorry, this was supposed to be .3, not .3, not .1, .3. Then to establish a connection with that. So after that, you create a peer with switch D. So peer 10.10.10.4, AS number here will be 10, and you establish a connection with the loopback interface. So peer 10.10.10.4 connect to loopback interface 0. After that, display and see if the IBGP has been enabled. So you can see the peer has been enabled. After that, we come to our switch C here. Switch C here is going to establish peer with switch A, switch B, and switch D. So you come to switch there, create the BGP 10. On BGP 10, the next thing we do is tell it to peer with 10.10.10.1. AS number here is 10. Then we connect it to the loopback. So peer 10.10.10.1 connect to loopback 0. Then you create a connection with switch B. So peer 10.10.10.2 AS number here will be 10. then you connect it to the loopback. So peer 10.10.10.2 connect to loopback interface 0. After that, you connect with switch D. Now peer switch D, so 10.10.10.4. AS number here will be 10, and tell it peer to connect to the loopback interface. So peer 10.10.10.4 connect to loopback 0. For that, to display and display this. So as you can see how the BGP are able to exchange. So it's open confirm, it's changing from open confirm to established. So it's established. So when you display, you can see it has been enabled on those interfaces. Then you come to this switch D here. Switch D here is going to establish IBGP and also EBGP. It's going to establish IBGP with switch C and switch B and switch A, and it's going to establish exterior border gateway with switch E on this autonomous system 20. So I'll quit, and you quit and create BGP 10 here. And on BGP 10 we are going to establish IBGP peer. So peer 10.10.10.1, and the next will be now AS number here will be 10. Then you tell it to peer to connect to 10.10.10.1, connect to the interface loopback 0, and also you connect with the switch C. So peer 10.10.10.2, S number here is 10. Then you tell it peer to establish a connection with the loopback. So 10.10.10.2. So we are going to tell it to establish a connection. So connect with the loopback interface 0. After that, we create also with switch C. So create a peer with switch C. So peer 10.10.10.3. AS number here will be 10, and I tell it to establish a peer connection with the loopback interface. So 10.10.10.3 connect to loopback interface 0. Connect to loopback interface 0. Loopback 0. On loopback 0. Then the next, after that, we are going to create now EBGP. We are going to create the EBGP with autonomous system 20. So peer here will be 10.10.2.1.2, and AS number here, autonomous system number here will be 20. So we establish exterior gateway protocol. So the state is up here. We are being told state has changed from open confirm to established. Now the next will be, and the status change reason is up. After that, display this, and let's see. You can see the status have been enabled. So after that, we are going to tell it to import the OSPF routes and also the direct routes. So import import direct route, import direct route, import route direct, and also tell it to import OSPF routes. Import OSPF process ID we used 10, and now display this and see. As you can see here, we tell it to import the routes. Then you come to switch E here. On switch E, here, you do the same. You create the EBGP with switch D. So say BGP here, this time BGP here, BGP 20, and BGP 20 we are going to establish peer with switch P. So peer 10.2.1.1, AS number here will be 10. AS number is 10, and the AS number is 10. After establishing the peer, the next thing we are going to do is we advertise the network, that connect to this router 1 here. So we are going to advertise that network of 10.3.1.0 so that our autonomous system 10 here, the networks on autonomous system 10 should be able to learn that route to 10.3.1.0. So you tell it IP version 4 family unicast, and you advertise the network of 10.3.1.0 wildcard mask of 30, and save. And let's display IP routing table. Display IP routing table and see. If we display IP routing table, we can see here the routes that have been learned through EBGP here are 10.3.1, and that is a direct route. So 10.10.10.1 has been learned through EBGP, and 10.10.2 has also been learned through EBGP. 10.10.3, 10.10.4 they have been learned through EBGP. So those are the network on autonomous system 10. And another networks that have been learned through EBGP here are 10.1.1.0, 10.1.2, 10.1.3.0, 10.1.4.0. Those are on IBGP on the autonomous system 10. And the protocol here, the default protocol for BGP is always 255. And the cost here, you can see the cost has been 2. So we were told to configure OSPF cost based on this switch 2 here, so that traffic will pass through switch B. So switch C here will act as the backup. So, and first of all, display IP routing table and see. When you display IP routing table, you can see the route that have been learned through IBGP is 10.3.1.0. So that is IBGP. Then when you come to this network and display IP routing table, when you display IP routing table, it has been learned through EBGP, meaning that this guy has learned that route from another autonomous system. So that is autonomous 10. But when you come to this switch C here, switch C here is telling you that it has learned that route through IBGP, meaning that it has learned it from switch D here. It does not learn it from switch E. It has learned it from switch D because it established an IBGP peer with switch D. But switch D here learned that through EBGPs, that is from a different autonomous system. So we said on this switch here, so interface VLANIF 20. We are going to configure OSPF cost of 2 so that switch B is selected with the higher preference. Then VLANIF 30. Also, we tell it give it a cost of 2 so that switch B is selected. After that, the next thing we are going to configure is now to configure OSPF BGP synchronization on switch B here so that during startup the service is not interrupted. So we say OSPF now you tell it stub router on startup. After telling stub router on startup, that synchronization OSPF BGP synchronization will be set up. This is the command. That is the command is stub router on startup. That will enable switch B here to run normally after startup. So that is it, guys. Let's save your configuration. I'll save on all the devices. And save also here. Say yes. When you come to this switch, also save. Save. Say yes. Save. So that you don't lose your configurations. Say yes, and also save it on the actual device here. Save it on the actual device, that is on the main topology. Then come to switch A here and display IP routing table and see. When you display IP routing table, you see here some routes have been learned through OSPF, that is 10.1.3 and 10.1.4 has been learned through OSPF, and also a route has been learned through IBGP, that is 10.3.1. So it has learned it from switch D here because we established an IBGP peer with switch D, and switch D has learned it from an external autonomous system. So after that, the next thing we are going, also there are some rules that have been learned through OSPF, that is 10.10.2, 10.10.3, 10.10.4. And we are going to check if can we ping that external network on a different autonomous system, that is 10.3.1.1. We are going to ping it from this autonomous system 10. So ping 10.3.1.1. So we are able to talk to our autonomous system. So like I said, autonomous system is just a group of IP networks managed by a single entity, and the entity here will refer to is the internet service provider, which uses a common routing policy. Also, while on this switch, let's see if we can ping. So ping 10 10.10.1 is also able to reach, that is, we are able to reach the loopback for switch 1. It's able to reach the loopback for switch 1, and also switch 3. It's able to go through and switch 2, switch B. It's able to go through, and also for our peer here .4, it's able to go through. So thank you guys, and I hope you've enjoyed this video. I'm here to bring you more of the concept of IBGP, so just follow through our video and you'll be able to learn much. So thank you.